You look at 18, you are bound first quadrant right off the bat. So you have a first quadrant problem. But then they give you a top. Y has to be less than or equal to 8. Y equals the number is a horizontal line through 8. So here's 0, 8, and it's working its way down. Okay? X and Y intercepts at 14 from there. So we plot our 14s. 14, 0. 0, 14. Take the earphones off. X through. That line also is working inward because 0 plus 0 is smaller than 14. So right now I have a boundary. And I also have a point. I can find that point rather quickly because I know that the y coordinate there has to be 8. So, what plus 8 is 14? So the ordered pair, there's 6, 8. That's exactly how you do it. You go to the next one. X-intercept of 10, y-intercept of 14. Oh, excuse me, 50. Now, I was just walking through this problem with JC a second ago. This line can come down in one of two ways. Well, actually, three. It could work where it's coming down in front of this 6 and 8, behind the 6 and 8, or heck, it could even go through the 6 and 8. I don't know for certain. So what I do know is that it has to cross this somewhere. Are we okay with that? So no matter what, whatever three of those possible scenarios there are, the y value will be 8. So what I'm going to do is just substitute in 8 for y right away to figure out what side of 6 it's going to land. Does that make sense what I'm doing there? Instead of trying to figure it all out. So if I put 6 in, I get 5x is 44. X is 8 and change. Which means it's on the right side. So I know it's got to work its way down out here. Sorry about the curve. But I also know that the boundary is working inward because 0 plus 0 is less than 50. Which gives me this point here. Okay? So all I have to do then is work with this. And you'll notice it's really, really easy because I can just rewrite it below and say x plus y 14. Subtract, I get 4x is 36. X is 9. 9 plus what is 14? 5. So this ordered pair here is at 9 and 5. The trick to that problem really is figuring out what do you do with that 50 because it's way up top. What side of that 6, 8 ordered pair do you play it off of? That's the trick. Okay? It's very, very easy to get this muddy. I'll let you substitute in them. Does that make sense? Better-ish? Yes, ma'am.
Wait, why did you use that equation? Like, you made it I'm confused.
For what?
So, like, you took x plus y equals 14?
Yeah.
But why did you do that?
Because I was figuring out where those two equations were intersecting each other. The x plus y equals 14, the 5x plus y is 50. Those two intersected somewhere, and I was just using a system of equation to figure out where. So I just subtracted all these.
Oh.
I used elimination. That's it.
Okay.
Okay? Yes, ma'am. Right over who's first? All right. What do you got? Yeah, what do you got? I'll put it back up.
You also have to find the point where the 0, 8 and the
10, 0.
Yeah.
Yeah.
You have to find that where that is the number, right?
Ah, no, because when we started to work with this one inward, this point here It's outside of their shared boundary now, of the full overlap. See how it's outside that boundary?
What? Is it because you already shaded past that?
Yeah. It's that double overlap. It's the idea when you're on a number line, and let's say this is 3, and this is 4, x is greater than 3, but x is also greater than 4. So it's going like this, and then it's also going like that. It doesn't fully overlap itself until it's out here. That's what that means. It's the same idea within double variable.
And you don't need it to do it because of
You're looking for the full overlap region. Yes, ma'am.
why is the number this one?
There should have been. Would have been at
I have this,
would have been at 0, I think, right? Because there's a bottom to it because it's got to be y is greater than 0.
oh yeah.
I think you might be looking at 19. That's why. I'm just 18
I'm
stuff.
I'm not for 18, why is it 0 and I'm still
What's the minimum value? 0.
So the minimum is 0 would be the same.
No. Difference. This is a great question. Before we get to 19 here, when you have a bounded region and you're getting 0 for a minimum, that means that your shaded region is stopped by some value. When you have something that has no minimum, it means your shaded region can continue to fall. There's no floor to it. Right? There's,
I got no minimum, but
it means 0. This means, for that problem when you said 0 is the minimum, no minimum means there's nothing there, you can continue to fall, there's nothing there to catch you. Same thing with no maximum, there's nothing there to stop you. Okay. I think, doesn't 19 have a no minimum, I thought, or an infinite minimum?
17.
Okay.
I thought 19 was.
Well, this one actually, when I was walking through this one a second ago,
This is number 20.
oh yeah, when I go through 20, you are still first quadrant. Where's first quadrant? Then I want to look at this one right away. Negative x plus y is 0. That's x equals y. There you go. Shading wise, we'll just pick our next equation when we go to graph it, use one of those points to shade both of them. X-intercept of 2, y-intercept of 4. So this point here, 2, 0, I know that this is going to be going outward. Okay? Is 2, 0? Is negative 2 plus 0 greater than 0? So this one is false down here, so it's got to be up here right now. Okay? I also have this point where they both ran into each other. Since I know that this is x equals y, I can substitute into here rather easily. I get 3x is 4. X is 4/3. Therefore, y is 4/3. For that first order pair. Okay. I do it again with the other one. 2x plus y is 13. I have a y-intercept of 13. And I have an x-intercept of 13 over 2, which is what? 6.5? This one is working inward. Okay? This one is working inward, so it's working through here. It's got a boundary here, so I need to find this point, because I am working now here, 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 and there. I've got that shape. These two lines do not intersect each other. You might be able to tell why. They have the same slope. They're parallel to each other. They both have a slope of -2. Okay? But I do need to figure out where these two guys intersect. And you can do that again very simply via substitution. X equals y. So I get 3x is 13. X is 13 over 3. Which means y is 13 over 3.
Who decided that we needed to learn all of this math? Like
Pythagoras.
why do we go to school for this?
Okay? So that gives you your 4 ordered pairs to go through.
How do we know what?
Because it makes us critical thinkers.
It's depending upon your shading. When you look for your shading, you have to. This is why I've told a bunch of kids in the past couple of days to draw these graphs a little bit larger, so that way you can use your arrows to see where things are being bounded by each other. Yeah. See how this thing's bounded out by those 4 points where the overlap shading occurs. That's what we're looking for. I got you. So I want to work on the next portion of this stuff. You still have to creating these little boundary things. You're still creating these style of a graph, but yet we're going to use it in a context of an actual problem. So instead of having you guys try to write all of this out, because it's kind of a pain, what I have here is the actual problems themselves for the first few examples that we're going to work on, already printed, and hole punched. Look at me, spare no expense. Sometimes I think it's going to count, and sometimes I say, eh.
You're a math teacher.
All right, hold this stuff because we're going to add to it tonight here, okay? And I want to read through you guys how these things are going to look. Oops, wrong one, sorry. I am going to start with the fundraiser one, as you get it. So, what we're looking at here I honestly don't have it. I've been on my computer. I have no idea. I swear. The one time I didn't pay that. Believe me. Thanks. I appreciate it. So what's going to happen here is we're going to try and maximize something. We're going to maximize something. We're going to figure out our best bang for our buck going through a style of a problem. So in this instance here, as you read through it, it says your club is planning to raise money by selling 2 sizes of fruit baskets. You plan to buy a small basket for $10 and sell them for $16, and buy a large basket for $15 and sell them for $25. The president estimates that you will not sell more than 100 baskets. You can afford to spend up to $1,200 to purchase the baskets. Find the number of small and large baskets you would need to buy in order to maximize profit. What you're doing here is you're buying some products and you're going to resell them at a margin. You want to make money. Okay? You have gone online and you bought a bunch of Chinese knockoff sports jerseys and you are selling them at a markup. It happens quite often. There's this thing out there called eBay. You might have heard of it.
No.
Yeah.
Wait, what's eBay?
So, as you read through this, what is the objective of this problem? What do they want to do? Yes, sir.
Me?
Yeah.
Oh, find the maximum.
Maximum what?
Find dot, a point, an intersection.
You're making it more difficult. What are they trying to maximize? Yes, ma'am.
I just want to see how much money we can.
Yeah, maximize profit. It's that simple. And you're trying to get the whole details of what do I have to do and do all that other stuff. The whole problem boils down to this. Maximize profit. The whole problem comes down to maximizing profit. So when I'm looking at this style of a problem, what I want to identify right away is my objective. Well, my objective here is to maximize profit. So that means that little C equation we were working with yesterday, where you would substitute in all your ordered pairs into, that's your main objective. That's your objective function. So I'm going to say C is going to equal some profit. Profit from a large basket, profit from a small basket. The only reason I'm saying large and then small is because it's alphabetical. Think of it as X's and Y's. Is that okay? So if I'm looking at it, I'm going to have some amount of large baskets I'm going to sell and some amount of small baskets I'm going to sell. But I'm trying to maximize the profit. How much profit do I make on every large basket?
$25. Oh, wait.
I'm looking at the large one. I know, because I put them in alphabetical order here. I'm buying them for 15, selling them for 25, so I make 10 bucks profit. On the other one, I'm buying them for 10 and selling them for 16. How much am I making? 6. Okay. So for every large basket I sell, I make 10 bucks. For every small basket I sell, I make 6. So if I sell one of each, I make
16.
Yay! All right, so you get the idea here. Now, look at what else you have. It says that you probably won't sell more than 100 baskets. Can I sell 100 baskets?
Yes.
Can I sell fewer than 100 baskets?
Yes.
So if I'm going to write this in terms of an inequality, I know that the maximum amount I'm looking at here is going to be 100 baskets. Is it going to be a less than or less than or equal to?
Less than or equal to.
Very good. Now, does it say anything about costs when you're selling just a basket? No. So isn't that just large plus small for your total? Large plus small. That was one constraint. Pretty simple. So we're not going to sell more than 100. What's the other one that's in there?
12,000.
Well, it's $1,200, but you know,
12,000.
smidge. So I have up to and including 1,200 bucks to spend, which means I have another inequality with the less than or equal to, up to and including $1,200 to spend. Well, how much am I spending per every large basket?
15.
15. And how much per every small basket?
10.
So it's 15 per large basket and 10 per small basket. Doesn't mean that I'm going to spend all my money on small baskets or all my money on large. There might be some way of a mixture of the two to maximize it out. Now for the tough question. Can I have negative baskets? No. So this is what I was saying, this becomes a first quadrant problem. That means that L has to be greater than or equal to 0, and S has to be greater than or equal to 0. We have some stuff going on, is right. Yes, sir.
I think I know where this is going, but couldn't you just divide the amount of profit you make by the amount of money that you're spending and find a percentage, and then the greater percentage means that you get greater profit per thing that you buy? So then,
Math.
so then you did.
I don't know, I have to look at how you're doing it.
So, I mean, basically you do 6.
He just said
divided
he
by
just.
10,
Hold on.
right, 6 divided by 10, which gives you 0.6%. Now, I divided 6 by 10 because 6 is the profit you make from the basket, and 10 is the amount of money that you're spending, which means that you were making 60 cents on the dollar. Okay?
Right.
Now, for the other one, you were making, right, I did 10 divided by 25, same reasoning, and I got 0.4, meaning I get 40 cents on the dollar. Meaning that it would be better, right, price per
unit.
per dollar, right?
Yeah.
To buy the small baskets, because per small basket I make $60, 60 cents on every dollar.
Okay.
So it would be more profitable to buy small baskets.
We'll check and see if your theory goes through. That's a hell of an idea. And you're right, in theory, when you're trying to break it down price per unit per dollar spent. But when we're looking at this, is there's the combination of the two. You're almost. Let me show you. Your reasoning isn't wrong, but there might be a combination that it works better one way or the other. Okay? It's a hell of an idea. It's a weak air 5. I knew better than that. There it is. So we know it's first quadrant. It's a great explanation. I've never heard that before.
See, this guy's gonna be busy.
Some of the, yes, there's sign them up. Get an econ class going. First part, we know that we have x and y intercept. Oh, before I do that, I'm going to label this L and this one S. That way I know which ones go where. I usually do that with the alphabetically. That way I know which one's x and which one's y. That's all. Okay. No, what should be?
So it doesn't matter which way?
It doesn't matter. It really doesn't. But I try to keep it that way. That way I try not to screw something up. All right. X and I have the intercept both at 100.
Yes.
I hope so. And we know we're working inward. I have an S-intercept now at 120. L-intercept, is it at 80? I think. Hey, looky, looky, they run into each other. Convenient, isn't it? Okay. Yeah, sometimes. So those two lines, they intersect each other. Oh, I forgot to shade. This one's coming inward as well. So my boundary is now here. Obviously, I have an ordered pair at 0, 0. I'm not going to make any money if I don't do anything, right? So we know we can throw that one out. But I need to figure out where this intersection is. That intersection is the intersection of those two. This one is pretty easy to work out many different ways. Whether or not you want to do a scalar and subtract, or substitution, it really doesn't matter. I'm going to do a scalar. I'm going to multiply the top one by 10. So I get 10L plus 10S is 1,000. Are we okay with that? And then all I gotta do now is subtract them. Because I have the same coefficient with the same sign. So I get 5L is 200. It's instead of what, I'm sorry?
Oh,
I multiplied the top equation by 10 and I just rewrote it with the bottom equation. Isn't that 40? And wasn't that what you were saying? You got your 40 and your 60?
Yeah, 0.4.
Yeah. Because is it 40 and 60%, 100% of your dollar amount you're spending? See where you're going with that? So if my L value is 40, what's my S value? 60. So I have to check, really only have to check 3 of these, because I know I'm not going to make any money at 0, 0. My ordered pairs are listed out L first. So I have the 0, 100, 40, 60, and then 80 and 0, if I'm not mistaken. Wait, what? We okay? I heard, huh? Sir?
Okay, why do we have to check all 3 points if it's pretty much determined that the point of intersection between those 2 lines is going to be the point where we maximize our profit?
Not always, because what happens is pretty soon I'm going to throw in another line. You'll have an extra set of variables to look
Okay,
at.
that makes sense.
So we have 0 plus 600, 400 plus 360, 800, and 0. So we make $600 here, $760 here, and lo and behold, if I just sell 80 of the large baskets, it works. I make the most profit. So, save your money, don't buy any small baskets, and just buy large baskets and sell them. Don't give people the option. Seriously, think about it. If you think about it in terms of bulk packaging, if you're buying something that there's already 2 of in a package, if there's 3 of them and it cost is negligible to get that 3rd one, wouldn't you just buy the one with 3 pack? But it's human mentality. Oh, more is better. Or, excuse me, it's American mentality.
Yeah, I was about to say,
more is
like,
better. Okay, and that's the idea. When you start to think about, are you really saving all that extra money at Costco and Sam's Club? Not really. You're just getting a lot more stuff. Price per unit was where it goes. Yes, sir.
Actually, I just have a little story. I went to Walmart about a month ago, and I was buying Reese's Puffs, and I was deciding whether to buy a bunch of little boxes or one big one. So I did the math, and price per Reese's Puff, per serving,
Yeah.
right? Per serving, they're identical. so you don't actually get more for your money.
It's true. It depends on the product. You are very right on that one. Peanut butter. We go through a lot of peanut butter at my house. My boys love peanut butter. I eat peanut butter. We buy the big tub of thing of Jif peanut butter, 4 pounds of peanut butter. Well, it's actually cheaper to buy the double pack. It's got a little bit less ounces in it, but when you do the math on it, price per ounce, it's cheaper to buy a smaller pack than it is the bigger pack, even though like, oh, more is better. Oh.
Maybe they did that to get you to buy it.
It's true. It's capitalism at its finest. But that's how we interpret these things. All right, let's flip it over. Let's see the
We
other
have a
one.
man in a suit and tie telling us about capitalism. I feel American.
What is this overwhelming American
All right. Let's take a second after you're off our phone. We're in the front row. Turn off your phone. Don't worry. I gotta find one of those. You are purchasing filing cabinets to maximize storage space. So right off the bat, it tells you what your objective is. It is to
Maximize storage space.
maximize storage capacity.
So now we're going three-dimensional?
Just read through the next lines here. The office has 60 square feet of floor space for the cabinets and $600 in the budget to purchase them. So you have 2 constraints right there. You only have up to 60 square feet to work with, and you only have $600 to spend. So you know right off the bat that it has to be less than or equal to 60, and it has to be less than or equal to 600. We don't know anything else except that we want to maximize storage capacity, storage space. So now you read the next line. Cabinet A needs 3 square feet of floor space, has a storage capacity of 12 cubic feet, and costs $75. Cabinet B, 6 square feet of floor space, storage capacity of 18 cubic feet, and it costs $50. How much should each should you buy? So go back to the idea of the maximizing of storage space. If I'm going to maximize my storage space, remember I had cabinet A and cabinet B. How much storage space was in cabinet A? 3. Ah, reread that. 12. It's 12. Storage capacity of 12 cubic feet. Floor space, it uses 3. Okay, so you just got to be very careful as you read that. So it says it has 12 cubic feet of storage. I'm sorry, what's that? No, I'm talking about, what I'm doing first here is I'm going to use maximize my storage space. I'm doing my objective function first. And then how much storage capacity did B? 18. Now if I go to my floor space, I had up to 60 square feet to put stuff in. A 6 by 10 room. To about the middle of the smart board. Yes, sir.
Okay, never mind.
Good answer. So if you have up to 60 square feet, how much floor space did A take up? 3. And floor space in B? 6. How much did A cost? And B? And for the most difficult question of them all, can you have negative cabinets?
Nope.
Nope. First quadrant problem.
Oh, yeah.
Isn't it still a cabinet? What's that? 75. It's like the second week of school. You'll get my handwriting down eventually. No worries.
Nope, never.
Okay?
Not once.
Now I have enough information to draw first quadrant.
Do you?
I do.
Swear to me.
I have a first quadrant problem. And now it's just a matter of getting my intercepts. I'm going to label A and B as an X and Y. I'll go A is X, B is Y. B has a y-intercept of 10 and A is 20. Good. Oops. Is it going inward or is it going outward?
Outward.
Ooh, reread that. Inward. Because 0 plus 0 is smaller than 60, so it's moving inward. So as of right now, here's my boundary. B intercept of 12 and 8. Need a pencil? You know what? You got lead in there still. So we had, what was it, 12 and 8, or wait, 8 for A, 12 for B? Well,
Congrats.
lo and behold, they hit each other again, and you have this inward spot.
Yay.
So what we need to do, move these down, I'm going to find the intercept between these two guys. Okay? There's a bunch of different ways to set this one up. What I'm going to do is I'm going to divide that whole top equation by 3. If I do that, I get A 2B is 20. So now I'm going to multiply it by 25. Or you can use substitution. JC, I took out a GCF, took out 3.
Yeah.
The reason why I'm multiplying it now, because when I rewrite this below here, if I multiply this by 25, I get 25A, 50B, and what's it, 25 times 20 is 500. I'm just eliminating B real fast. I figured 25s and 50s, that would just be really fast. If you want to use A and do substitutions, by all means. There's no right or wrong way to do a linear combination. It's just, unless you're wrong. And don't do it that way. I have the same coefficient, same signs with those 50s. If I subtract those out, they go away. So I wind up with 50A is 100. What's A? Okay. If A is 2, 2 plus 2B is 20, 2B is 18, what's B? And now you have your ordered pairs. Okay? And now you have your ordered pairs. You test it. We have 0, 10, 2, 9, 8, 0, and I'm going to throw out 0, 0. I hear this big giant what?
That logic there, like I don't get what you just did.
Math.
Okay. What did you multiply 3A plus 6B is less than or equal to 60 by?
What I did here is I had a GCF of 3. I factored out a 3. I divided everything by 3. This becomes A, 2, and 20.
Okay.
I was just making it easier because I saw 75, 50, and 60. I knew that if I can get this to a 2B, I can multiply it by 25 and get 50. Multiply that by 25, I get 25.
Okay.
Multiply that by 25, I get 500.
All right.
I basically multiplied it by 25 thirds.
Okay, sure.
How do I get rid of
All right, I
the
get it now.
I subtract.
All right, I saw it.
I could have substituted, yeah. I probably would have made your lives a lot easier if I would have substituted, but
why would you do
showing
that?
you, if I do it another way, sometimes it's a little bit faster. Okay? By all means, guys, just use substitution. A equals 20 minus 2B. Substitute it, you're going to get the same result. Okay? So now if you substitute all those three, yeah, Mr. Soto, what do you got?
test, will we be graded on the answer that we get or on the way that we
Guys,
make it?
I'm sorry, I can't hear you. People are talking.
Okay, on the test, will we be graded on the answer that we get or the way that we solve to get the problem? Because I know that here we're learning about inequalities and how to graph them, so I assume that it matters somewhat.
We'll talk about it more tomorrow.
Okay, as long as it's project problem.
So as you substitute in, you get 0 plus 180, 24, what's that, 171? 162. Oh yeah, duh. 162. And 12 times 8 would be 96. So if my math is right, I want to buy 2 of cabinet A and 9 of cabinet B to get the most storage capacity possible.
That doesn't work for OCD people though.
Well, I'm sorry.
You should be.
I do want to give you, because we have a few minutes here before, I have another one, and I'm going to hand it out to you here in a second. I want to set up, I want you guys to set up, before we get out of here, one of them on your own. And it's going to look like this. I honestly don't know where to start.
He's not strong though, so his didn't help.
You guys are always talking when he's trying to do it. It's actually really oh, I talk way much. I talk way more than you guys do, but I keep it on the down.
No, he notices as much.
Half the time we're just like mouthing. Just like we're talking.
Well, he just hates you, right? Happy birthday.
No, well, part of it will be.
Did you just like give her
So-
a present?
Let's start looking at number 1.
Are you
I want you guys to take a minute. I want you guys to take a minute, and read through it on your own. Decipher exactly what are you trying to maximize, and then what are you being constrained by. I want to give you a few minutes to set it up, because once you get through the setup, the problem's easy. It's the setup. Identifying what you're trying to solve for.
Profits.
Max profits, how many tourist seats did you sell? So there's actually 2 parts to the final answer. You want to maximize your profits, but they're asking you not about what your profit should be, but how many seats of the tourist should you sell. So depending on how you set it up, you should be able to, your order pair might be either way. All right. So you know you want to maximize profit, so your constraint or your objective is to maximize profit. Well, you've got 2 seat classes. You have business and tourist. I'm going to use B and T.
creative?
I am. I'm something. How much profit do you make on a business class seat? And how much do you make on a tourist? All right, so you are almost done. Now, go through the rest of it. In order to charter a plane, at least 5 business class tickets must be sold, and at least 9 tourist class. So you have to have the bare minimum. B has to be greater than or equal to 5. T has to be greater than or equal to 9. That took care of that. Because you can sell 5, you can sell 6, 7, 8, whatever. But is there a cap on how many fit in the plane? 30. The combination of business and tourist, very good. And that's all there was, isn't it? Can you have negative seats? No. First quadrant problem.
I'm not sure if that was a compliment or
I don't know what I'm looking for. Missed something. I'll put B on the X, T on the Y. So if B equals 5, is that a horizontal or vertical line? Well, you had 50-50 chances. You spoke up. You were wrong. So if B is on my x-axis, it's a vertical line through 5. On the other hand, then, T would be a horizontal line through 9. Now, it had to be greater than 5, and it had to be greater than 9. These two ran into each other where? Perfect. 5 and 9. Vertical is your x, horizontal is your y. They ran into each other at 5, 9. Starting to look similar to the ones you were working with yesterday where you had that boundary between 0 and 60, 0 and 40. Same kind of idea here. X and y intercepts of 30. Bless you.
Bless you.
And it's got, this time it's moving inward, so you get this little triangle in here. Now, depending on how you scaled it, it might look cleaner than others. What's nice about the intercepts of that triangle, you know the y-coordinate here has to be what? 9. You know the x-coordinate here has to be 5. Now the rest of the math is easy. What plus 9 is 30?
21.
What plus 5 is 30? So we know that this has to be 21, and that's 25. Do you have your ordered pairs to figure out which one of those can give you maximum profit?
Yes.
The idea here is to not be overwhelmed by the minutia within the problem. You want to look at it and read it carefully, and it will say maximize this, maximize that, and then just start peeling away at it, okay? I want you to try and finish out the 4 of them on the page. Don't worry about number 5. Number 5 is written a little weird. I'm not going to get into that one probably. I don't know if we have enough time to. So do your best on it. At least get through the ideas of quadrants that will be placed, the objective of what you're trying to do, and look for specific parts they're talking about. Are they talking about money? Are they talking about space? Are they talking about capacities, time, whatever? There are certain restrictions. Start peeling it back. Keep your X's and Y's alphabetical. It's the easiest way. Otherwise, I mean, I did this third hour. I flip-flopped and then I got my answers all wrong, and that happened back. Okay? Make sure you get your chairs up for me, though, okay? Yeah, go 1 through 4. Well, actually, 2 through 4 now.
Sorry, what's the answer? Yeah, what's the answer?
I don't know. You have to go through and substitute in those 3 ordered pairs to figure out which one gets your max, and then go off of there.
Or you just look at the fact that the question is multiple choice.
Well, it is multiple choice, but you don't know which one works, so you still have to substitute in.